Friends, here we are given a quadratic equation x square minus mx plus 4 equal to 0. And we are also given that roots of this equation are real and distinct. Okay, they are not complex roots. That means this equation is touching x-axis not once but twice because they are distinct, right? It is touching x-axis twice. And that means this is not a perfect. So b square minus 4ac is not 0. If it is 0 means it is touching x-axis only once. If it is greater than 0 means it has got two roots. Okay, they're real roots, not complex roots. And they lie between the interval 1 and 5. Let us first try to draw the graph of this equation. Okay, then what is the value in which m can lie? Okay, firstly, for ax square plus bx plus c, for an equation like this, if a is greater than 0, a is positive, that means the graph will face upwards. We already know this. Why? Because when x is large, this ax square, when x is large, this one will dominate. These two will become very small. When x becomes very large, like 100 or 1000, these two terms will become very small and this will dominate. And that's why the overall expression will be positive. So it will face upwards. When x-axis is like this, x becomes large, this equation, this parabola should be positive. That's why it is facing upwards. Now, this equation is stretching x-axis twice. Means x-axis is somewhere like this. Okay. Now, what are those 2 points? These 2 points, wherever they are touching, they should be between 1 and 5. Let's say this point is 1, this point is 5. The roots are between 1 and 5. The roots are between 1 and 5. Right. That means the graph will be something like this. Okay. So firstly, there are two real roots. What does that mean? Discriminant should be greater than 0. Two different roots. That means b square minus 4ac should be greater than 0. That means what is b square? M square minus 4 times 4, 16 should be greater than 0. M square should be greater than 16. Or m should be less than minus 4, or m should be greater than 4. Right. M square minus 16 is uh, greater than 0. Right. M can be less than minus 4 or m can be greater than 4. In that case, m square will be greater than 16. So far so good. Is this sufficient? No. We need to fulfill other conditions also. So for example, if b square minus 4ac is greater than 0, that means this equation is touching x-axis. It can happen like this also, right? The roots can be like this also, right? So here it is nowhere we have used the requirement that they are lying between interval 1 and 5. Here this one will just say that the graph is touching x-axis. Okay, so then we need to fulfill other conditions also. What are the other conditions? This the root should lie between 1 and 5. Okay, what does that mean? What does that mean? What that means is f of 1 should be positive, f of y should be positive. Right. So the graph will be like this. For example, if f of 1 is negative, what does that mean? The graph can be like this. Right. F of 1 is negative. That means graph is somewhere like this. That means one of the other root will be towards the left of 1. We don't want that. Right. If of 1 is negative, what does that mean? If the graph is facing upwards, one root is to the right of 1, another root is to the left of 1. Right. What does that mean? If f of 1 is negative, that means one root is to the left of 1, another root is to the right of 1. Right. Which is we don't want that. So that's why we want f of 1 to be positive, f of 5 to be positive. Right. F of 1 should be greater than 0, f of 5 should be greater than 0. Okay. Is this condition sufficient? F of 1 is greater than 0, f of 5 is greater than 0, and b square minus 4ac is b square minus 4ac is greater than 0. Is that sufficient? That is not sufficient. Why? because we can still draw a graph like this. Okay, in this case also f of 1 is greater than 0, f of 5 is greater than 0. What we want to put one more condition. What is that condition? This vertex, sorry, this vertex, this vertex should lie between 1 and 5. Vertex should lie between 1 and 5. What is the vertex? The lowest point of the parabola. That should lie between 1 and 5. Then only when the case, when f of 1 is positive and f of 5 is positive, then the graph will look something like this. The graph will look something like this. Otherwise, so we have three conditions. V square minus 4ac is greater than 0. That means two real roots. Okay. Then vertex between 1 and 5. Vertex between 1 and 5. And this condition alone is not sufficient. Why? Vertex, this is 1, this is 5. If vertex is between 1 and 5, then still we can create a graph like this. That condition is not sufficient, right? If vertex is between 1 and 5, x coordinate of vertex. When I say vertex, it means x coordinate of the vertex. Y coordinate could be anything. If x coordinate of vertex is between 1 and 5, we can still create a graph like this, where one of the roots is before 1, or we can still create another graph like this, where one of the roots is before 1 or after 5, or in fact, we can create a graph like this, where both roots, vertex is still between 1 and 5, and both roots are not between 1 and 5, right? So this condition, these two conditions are still not sufficient together. We need one more condition. What is that condition? F of 1, f of 5 should be greater than 0. Okay, so these three conditions will force us, the vertex is forced to be between this and this curve. This curve is compressed in such a way that both these lines are falling between 1 and 5. That only then f of 1 is greater than 0 and f of 5 is greater than 0. We are forcing these two sides, we are compressing these two sides to fall between this and this. Okay, that is the third condition. First condition means, first condition b square minus 4ac is it will touch x-axis. It is facing upwards and it will touch x-axis. That is the first condition. Second condition is bringing this point between 1 and 5. Okay, that is vertex between 1 and 5. Meaning vertex between 1 and 5 means x coordinate of the vertex. Okay, the vertex can be here, it can be here, it can be here, y coordinate could be anything. X coordinate is between 1 and 5. What is the third condition? Then compressing both the sides so that these 2 points are between 1 and 5, right? So how do we compress? When f of 1 is greater than 0 and f of 5 is greater than 0, what that automatically means is this line, the line connecting this vertex and this point, whatever, will fall on, will touch x-axis between 1 and 5. Okay, these are the three conditions. First condition has given x should be less than minus 4 or greater than plus 4. Okay, so that is this condition, condition number 1. It is given this. Okay, x is less than minus 4 or x is greater than 4. What is the other condition now? The vertex of parabola should lie between 1 and 5. That is this vertex. Vertex is between 1 and 5. The parabola can be like this. The parabola can be like this, whatever. That is vertex between 1 and 5. What is the formula for vertex? Vertex we mean x coordinate of the vertex. What is x coordinate of the vertex? What is this point? This point is minus b by 2a. X coordinate of the vertex. We know this. Right. Here what is minus b? Which is m by 2a. A is 1, m by 2. It should lie between 1 and 5. It should lie between 1 and 5. That means m should lie between 2 and 10. This is the second condition. Okay. In our graph, m should lie between 2 and 10. This is the condition number 2. Okay. This is as per condition number 2. Now, all three conditions should be satisfied. What is the condition number 3? F of 1 and f of 5 should be greater than 0. F of 1 is 1 minus m plus 4. 1 minus m plus 4 should be greater than 0. That means m should be less than 5. That means m is between minus infinity to 5. Similarly, f of 5 should be greater than 0. That means 25 minus 5m. We are just substituting 1 here. Sorry, 5. 5 square, 25 minus 5m plus 4 is should be greater than 0. What does that mean? 5m should be less than 29. M is less than 29 by 5. Okay. This is our condition number 3. Condition number 3, we have two parts. First part is saying m is less than 5. That is condition number 3. M is less than 5. That is condition number 3. First part. M is less than, M is less than 5 is this part. This line, M is less than 5. The second part is M is less than 29 by 5, which is roughly 6. That is this part. M is less than this. Right. We have condition number 3 and 3 this one. Condition number 1 this one. Condition number 2 this one. So which area is satisfying all the three conditions? This area, right? The area between 4 and 5. 4 and 5 is the area where all three conditions are satisfied. Right. So the correct answer is 4 and 5. That is the correct answer. 4 and 5 is the correct answer. Right. So it is very important for us to understand the graphical interpretation of this equation. Then we can solve this very easily. Right. How roots can lie between 2 points. What we have discussed. For example, if there is a graph like this, firstly, when b square minus 4ac is greater than 0, that means it is touching x-axis at 2 points. We don't know whether y-axis is here, here, here. It doesn't matter. Okay. We can only say it is just touching x-axis. Now, if the vertex is between these 2 points, vertex is between 2 points, okay, we can ensure vertex is between this, but we cannot guaranteely ensure that the roots are still between these 2 points. Right, vertex is here, vertex is between these 2 points, but we can always draw a parabola like this, where the roots are not between these 2 points. Now we have to bring these two lines also between these 2 points. How do you bring these two lines? When f of this point is greater than 1, right? And f of this point is greater than 1. That means when you are connecting this vertex to that point, to this point, automatically this line will cross x-axis between these 2 points. Between these 2 points, that means these two roots are between these 2 points. Right, guys? It's a very logical thing. We need good understanding of location of roots for solving these kind of problems. Hope it is clear. Thank you, guys. Hope you understood this. Thank you. The correct answer is 4 to 5.